Hi, everyone. So today I'm going to be talking about chiral molecules. So you're about to get a really brief overview of about 3 semesters worth of chemistry here. So I want to start at the basics. So I want to start by talking about atoms. So atoms are basically make up everything around you. So atoms are composed of electrons, neutrons, and protons. So over on the right, we can see the structure of atoms. Some of you have maybe seen this depiction that's all the way over on the right. So that is just an atom with the electrons, neutrons, and protons. And all elements on the periodic table are actually one type of atom. And atoms make up molecules. So these atoms are connected through bonds. So here we can see a water molecule that is made up of 1 oxygen atom and 2 hydrogen atoms. And in molecules with single bonds, these atoms can actually freely rotate without breaking that bond, as you can see here in this GIF. And this is important because some molecules can rotate plane polarized light, and these are said to be chiral molecules. So the main topic here. So chiral molecules are optically active, which means that when a beam of plane polarized light, so just regular light from any light source, passes through a chiral molecule, it's going to interact with that molecule in a way that produces a light filter. And this is actually how polarized sunglasses reduce glare. So a chiral molecule is applied to the lens to filter out half of that light. And with chiral molecules, it's also important to talk about enantiomers. So equal and opposite chiral molecules are enantiomers. And a pair of enantiomers will always rotate plane polarized light to an equal but opposite degree. And an interesting fun fact is, again, with those polarized sunglasses, if you had 2 pairs and you held them up to each other and held one vertical and one horizontal, so they were perpendicular to each other, where they overlapped, would actually not allow any light through. So it'd be completely black. You could not see through it. And again, this is just because of that equal but opposite degree of rotating plane polarized light. Another way to visualize enantiomers is to think of a molecule and its mirror image. So here we can see molecules A and B. They're actually not the same molecule, even though they look very, very similar. They're actually enantiomers. So for a molecule or an object to be chiral, we have to discuss a few things. So first, that molecule has to contain at least 1 chiral carbon. So a carbon is an atom, again, on the periodic table. And a carbon is going to be chiral if there are 4 atoms or groups of atoms attached to that carbon. And all 4 atoms or groups of atoms have to be different. Over on the right, this top image, this carbon that I am pointing to, this carbon atom is chiral, and it's because it is attached to 4 different atom groups, again, that are completely different from each other, as depicted here with these different colors. Where the second one, I'm pointing at the 3 other carbons in this same molecule that happen to be achiral. And these are achiral because although they do have 4 atoms or groups of atoms attached, they're not all different from each other. So that makes them achiral. Also, for a chiral molecule to be chiral, its mirror image has to be non-superimposable. So a really easy way to think of this is to hold up your hands, look at them. You can see they're mirror images of each other. But if you try to put one on top of the other, they are non-superimposable. So here we can see that with these same molecules A and B that are enantiomers, they cannot be superimposed with each other. So specifically, you can see here that they're actually not the same molecule. So chirality is really important to understand because most biological compounds are chiral. So it's important to understand how these different enantiomers are going to react within our body, especially when we're thinking about pharmaceutical drugs. So in the 1950s and 1960s, there was a big problem with thalidomide, which was a drug that was used to treat morning sickness in pregnant individuals. And thalidomide caused severe birth defects in over 10,000 babies worldwide and had a pretty high mortality rate. So the drug contained a mixture of both enantiomers of thalidomide. And this whole situation prompted tougher rules for testing and licensing of drugs, again, including understanding both the enantiomers of molecules and how they interact with our body. So over on the left, you can see one enantiomer of thalidomide, and you can see its mirror image on the right. So the mirror image on the right is the teratogenic enantiomer, or the one that's causing birth defects, where the one on the left is actually the effective enantiomer that is actually treating morning sickness. So I hope you've learned some things, some new things about chemistry and chiral molecules. So just to recap, everything is made up of atoms. Atoms are connected through bonds and make up molecules. Some molecules filter unpolarized light, and these are called chiral molecules. And when an object and its mirror image are non-superimposable, they are chiral. And equal and opposite chiral molecules are called enantiomers. And understanding these enantiomers is very important, as most biological compounds are chiral. So thank you for your attention here today.